A scientific paper about hypothetical living organisms on Venus? The same brightness of planets? Jupiter as a failed star? In this video, we are going to have not one, but 3 separate segments. These are myths, misconceptions, or just weird stories. And today, all of them are about planets of our solar system. Let's begin with not a myth, but rather a weird story, and this one is the weirdest of 3 for me. Last spring, people saw headlines: scientists found signs of life on Venus. And that wasn't completely made-up news. What's weird that it was based on an actual article in an actual scientific journal. Here it is: hypothetical signs of life on Venus. Yeah, it says hypothetical, but let's look at the article content itself. So what is it about? The first point: scientists are looking only for the life as we know it, but perhaps alien life could be not based on carbon and not require water. It may have a different biochemistry. This idea isn't new. Even Carl Sagan talked about carbon chauvinism. The next idea is based on the previous one. Allegedly, scientists in general do not consider modern Venus to be capable of sustaining life as we know it. Temperature at the surface level is over 400 degrees Celsius. Atmospheric pressure is 92 times higher than on our planet. And also 96.5% of the atmosphere is carbon dioxide, mostly no oxygen, and so on. Then authors reflect on the possibility of the existence of life with different biochemistry in harsh environment of Venus. Well, fine, why don't we talk about it as a hypothesis? After all, again, this idea isn't new. In this context, you could have heard about Saturn's moon Titan. In this case, the hypothesis comes from the measurements of atmospheric chemical balance of the moon. Perhaps something is consuming hydrogen and acetylene. But what about Venus? What evidence do they actually use to talk about hypothetical life? The article tells us about Soviet missions to Venus, the only spacecraft program that reached surface of Venus to date, and specifically about images of Venera 9, 10, 13, and 14. Allegedly, on those photographs, there are some distinct objects that look like Earth life forms, and they even move. So, 40-year-old images were reprocessed, quote, using state-of-the-art technologies that enabled image details to be substantially improved. I tried to find a detailed description of those technologies, but here is the next weird thing. That's what it says about reprocessing. The processing of the initial images completely ruled out their retouching, filling in, additions, or corrections. The contrast and brightness of the images were corrected. If the image structure allowed, a sharpness enhancement operation was applied together with a low spread level of standard Microsoft Office Windows programs. Up to 16 codes were used, including special programs developed for processing images of Mercury. I couldn't find any more information on those 16 codes, but what we do know is that they tweaked contrast and sharpness or clarity. Can you find anything fundamental new in this case? Well, let's see. This is an old version of a panorama. This is a new reprocessed one. It has changed geometry, tint, and apparently contrast and clarity. As we can see, it's hard to say that there is some drastic difference. And that's not even saying that without having a raw image that contains a lot of information, by over-sharpening an old image, we could just bring up more noise and artifacts instead of useful data. But in this article, this is the main evidence. And that's where the weirdest part begins. There is a list of 18 objects that may be hypothetical life forms because they resemble some Earth organisms. They have code names, for example, a lizard, a mushroom, flowers, a scorpion. Well, I don't even know what to say. Stones looking like something alive? I think I've already seen it somewhere. Oh yeah, ufologists that see humanoids or other creatures in the images from Mars. This kind of scientific articles seemed very weird not only to me, but also to several astrophysicists who I discussed it with. I'll leave a link to the article down below so you can check it out for yourself. This story is probably the least obvious one, but somehow I keep hearing this question from people. So what's wrong with planet's brightness? And I have to say that if you're familiar with at least basic principles of photography, this one is going to be very easy for you. So what's the issue? Some people ask, if planets in our solar system are at different distances from the Sun, so then why do they appear to be the same brightness on photos? The logic behind this is the following. The farther the object from the light source, the less light it receives. In case of our solar system, we can easily calculate how much less light a certain planet receives compared to the other planet. We can compare our Earth and Saturn. The average distance between Earth and the Sun is 1 astronomical unit, which is about 150 million kilometers. Average distance from Saturn to the Sun is 1,434 million kilometers, which is a bit less than 10 AU. We can say that Saturn is approximately 10 times farther from the Sun than our planet. How much light Saturn receives is inversely proportional to the square of the distance. If Saturn is 10 times farther away, it gets 100 times less light. But then people look at images like these and ask, why does Saturn not look 100 times dimmer? We're not even gonna touch on reflective properties of bodies, because here it's mostly all about how cameras work. This is actually very similar to people asking why there is no stars on photographs of Earth's and Moon's day sight. Cameras can collect light during extended periods of time, and I'm talking about such parameter as exposure time or shutter speed. How long the shutter is open and digital sensor or film collects light. Changing this parameter, we can make a dim object appear brighter on photos. Well, that's actually one of the basic principles of astrophotography as well. But there, I made a very simple example of how just changing exposure I could make two of these globes look about the same, while in reality the one on the right is much dimmer. As for Jupiter, this one is very popular. It's not actually rare to hear people call Jupiter a failed star. There are some reasons for that, but why it's not really correct to do so. Let's start with why people say that. And firstly, of course, it's chemical composition. Most of Jupiter's mass is hydrogen and helium, just like our suns and other main sequence stars. I would also mention the fact that there is only one star in our solar system, while most of the stars in our galaxy are in binaries or other multiples. And some might think that Jupiter, being the second most massive object in our solar system, is the best candidate as a companion for our Sun. The reason why Jupiter is not a star is simple: lack of mass. Yes, if it were much more massive, with its chemical composition, theoretically pressure and temperature inside could rise enough to start nuclear fusion reactions and basically become a star. But how massive Jupiter needs to be? Maybe 2 times more massive or 4 times? Actually, mass shortage is huge. Jupiter's mass is only 1,000th of a solar mass. But we should compare it not with the Sun, but rather with the least massive stars. Red dwarfs. Their masses vary from 50 to only 8% of solar mass, perhaps even 7% in case of SCR 1845-6357. So Jupiter has to be at least 70 to 80 times more massive to be able to sustain long-term nuclear reactions in its core, and it's a far cry from a necessary mass. But that's not all. It also had a different formation process. A star is born when a part of giant molecular cloud of gas and dust collapses under gravity. The remaining matter forms a protoplanetary disk, and planets in turn form in that disk. As for gas giants, we don't know for certain how they form, but there are 2 main theories. According to one theory, the first stage is formation of a solid core out of heavier elements, and this core is supposed to be as massive as 10 to 20 Earths. Then runaway accretion starts, and this core accumulates remaining gas, gaining the most mass and forming outer layers. The second one is called disk instability model. According to this theory, clumps of dust and gas are bound together, and those clumps compact and form giant planets. But if for some reason we just want to use the phrase "a failed star," brown dwarfs would fit this role much better. Firstly, they form probably more like a star in the collapse of a gas cloud. Secondly, their mass is much closer to that of a star. For example, the first confirmed brown dwarf ever has a mass of about 55 Jupiters. And finally, they are even thought to be able to sustain short-term thermonuclear reactions. Thanks for watching. Links to all the sources and articles are down below in the description. If you liked this video, subscribe. Bye!